Hey guys, Mr. Wilson here. Today we're going to talk about angle measures and segment lengths. At the end of this video, you should be able to find angle measures within circles and segment lengths within circles. Alright, so we're going to throw a couple theorems at you, put them into practice with some examples, and then we'll have some practice for you. Alright, so first thing, finding the angle measures. The measure of an angle formed by two lines that intersect inside a circle is going to be the sum of the measures of the intercepted arcs. Okay, now when we talk about intercepted arcs, here are intercepted arcs x and y. Okay, you see that our chords intersect these arcs. Okay, they're included inside of our lines that intersect. Okay, and like we said, it's going to be half the sum of them. So to find the measure of angle 1, it will be half of the measure of the sum of x plus y. So if it's inside, it will be half of the sum. Okay, if the two lines intersect outside of the circle, then it will be half of the difference. Okay, and that can happen a few different ways. You can look at different ways. So here we have an angle that's created from two lines that intersect outside of the circle. Okay, notice that x and y are still the arcs that are intercepted inside those two lines. X and y, here we have a tangent line and a line that goes through twice. Here we have two tangent lines. Okay, but in any case, it'll still be, the measure of this outside angle will be 1/2 x minus y, the difference between the two. Okay, and always take the bigger number first. That way you keep your angles positive. There's no such thing as a negative angle for us. Okay? All right, so now looking through, let's do a few examples. I'll actually have you guys complete number 1. It's inside the circle. Should fall into that category. Do that so that I know that you're paying attention to the notes and not just writing it down. All right. Number 2, we see two angles that meet, two lines that meet outside of the circle, and so this is a little bit different than what we're showing up here, just because we're not looking for the measure of this angle. We know the measure of the angle. Actually, let me set it up like this. We know that because these meet on the outside, we should plug it in like this. Measure of the angle will be 1/2 of the difference between the arcs that are intercepted. Well, the measure of the angle is 20. We know that. They told us that. The measure of the big arc is 95. And we don't know z. Okay, that's the arc that we don't know. So now we have a problem to solve. I will multiply this by 40. Multiply both sides by 2 in order to get rid of this 1/2. That leaves us with 95 minus z. Okay, subtract 95 from both sides, and so we get negative 55 equals minus z, and so we find out that z is 55 degrees. Oops, sorry guys. All that was said out loud, so hopefully you can see the work and make that make sense to you. Alright, for number 3, again, we're given this outside angle. Now this is a tough part in the sense that we don't have any numbers here. Okay, we know that the outside angle is 50. It should be 1/2. I'm going to call this x, because that's what we want to find. We want to find th, and I'm going to call this y. Okay, so 1/2 x minus y. Okay, now the problem with setting the problem up this way for this specific problem is that we have two unknowns. I don't know what x is, I don't know what y is. But what I do know is that the entire circle is 360. Okay, the entire circle will be 360. So since WH is 100, okay, the rest of this has to be 260, correct? And so since the rest of it's 260, what I'm going to say is I'm going to say that this is x. I'm going to rewrite this as 260 minus x. So basically the rest of 260 after we take x away. Then I want to plug these arcs in and solve. 1/2 x minus 260 minus x. Okay. Now I want to make sure I do that so that when I take this out of its parentheses, I understand that I'm taking away negative x. I'm basically adding x. Okay. Alright, so that's 1/2, 50. So now I'm going to solve it. I'll multiply both sides by 2 again. 100 equals, combine my like terms, 2x minus 160. Okay, I'll then add 160 to both sides. So I get 2x equals 260. Divide by 2, and then I get x equals 130. Or this is 130. Do that correctly? Doesn't feel right. Nope, sorry. I changed 160 to, or 260 to 160. Okay, so that should be 260 here, which gives us 360, gives us 180. All right, way better. Okay, so this value is 180. They didn't ask us for this value, but this value then would be 80. Okay, and so we find that the measure of arc T8, like they're asking us, is 180. Okay, maybe they should have used more than 2 letters. Okay. All right, going to the next thing. Okay, remember to do that first example there as you turn in those notes. Going to the next problem, we have theorems about segment length. Okay, now for segment lengths, for a given point and circle, the product of the length of 2 segments from a point to the circle is constant. So the product of the lengths of 2 segments from the circle to the point is constant. Constant. Okay. So here is the situations. We can have a point inside the circle. Okay. And so the point referred to in this problem is point P. Okay, point P right here. For the pink line, the lengths of the segment from point to the circle are represented by A and B. Okay, so what we see is from the circle to the point is A. From the circle to the point is B. For the blue line, they are C and D. And so what we're saying is, hey, the product of A times B will equal the product of C times D. Okay, it's always going to be that way. Situation 2 is we have a point outside the circle and a tangent line. And one of the lines is tangent. Remember, tangent means it touches the circle exactly once. Okay, for the pink line, the lengths of the segment from the point to the circle are y, okay, because we're going from point P to the circle, and then y plus z. Okay, and the reason this is because we go from this side to the point now, okay? So we've got to go from here, which is z, plus y. Okay? For the blue line, we go t, because we can go from the point to the circle, but it only touches the circle once, so we had to go basically back the same way. And so therefore our theorems tells us that we have y times y plus z, y times y plus z equals t times t, or t squared. Alright, and then finally, the third situation is we have a point outside the circle with no tangent lines. Okay, and so for the pink line, we see the point from the point to the circle are y and y plus z. Again, the same reasoning. So we go from the circle to the point that they intersect, that's y, and then from the circle to the point where they intersect where we're adding y and z. For the blue line, we have w and w plus x. Okay, again, from w, the circle to where it intersects, and then from the circle to where it intersects. And so we have y times y plus z equals w times w plus x. Okay. From there, we should be able to solve for the distance of these different segment lengths in the circle. So let's see how that works out. For number 1, we have 6 and 8, 7y. We're going to want to identify what's happening. It's a point outside the circle with no tangent lines. So I can set up my equation as follows. Okay, 6 times 6 plus 8, I'll write that so we can see how that's going, equals 7 times y plus 7. Okay, so we're getting 6 times 14 equals 7y plus 49. Okay, here I'm just multiplying here. On this side I'll get 84. I'm going to write that down here. 84 equals 7y plus 49. So now I'll subtract 49 from both sides. That will give me 35. So 7y equals 35. And y then will equal 5. And we can make sure that that works out. Plug that in. If we did, we'd have 6 times 14 equals 7 times 12. They are both 84. So it does work out. Okay, we know that our product is going to be the same. All right. Number 2, we see two lines intersect inside the circle. And so we know that we should have 7 times 7. Okay, because from center to from the circle to where they intersect to 7, from the circle to where they intersect to 7, equals 4.8 from here to here times x. So we have this 49 equals 4.8x. We'll divide 49 by 4.8, and I can do it up here. 49 divided by 4.8, 10.21. Okay. The next will give us 10.2, I'll say 1. Okay. And then finally, we have the situation where we have one tangent line, or the point meets on the, or the lines meet on the outside with one tangent line. And so we have z squared equals 8 times 8 plus 16, which is 24. So that gives us 192. Z squared. Have to take the square root of 192, which is 64 times 3. 8 times 8, 8 radical 3. And so we find out that z is 8 radical 3. We could leave it that way. If they asked us to, we could put it as a decimal as well, 13.9. 13.86, I like that better. Okay. All right. So a couple different situations you'll have to familiarize yourself with, but with practice you'll get these down. All right. See ya.